I'm Merrill Cook, Head of Content at Diffbot. Welcome to our first weekly webinar, where we're going to talk through the pros and cons of rule-based versus ruleless web data extraction. So I see a few people are here. Can anybody give me a thumbs up in chat just to let me know you could hear me and you could see my presentation on the screen? Cool. So first off, I'm going to pull up a little poll, which you should see to the right of your screen. Basically, I just want to see what level of familiarity our audience has with web data extraction. This should show up in on-demand async viewings of this in the future, and I'll check back through this webinar. Let's see. Should see that over in the chat portion of the window. And meanwhile, let's go ahead and get started. So what I wanted to start with is the question of why extract web data. First and foremost, the web is our single largest repository of data, and a great deal of it is public. It's the only place where you can get data from the digital footprint of hundreds of millions of long-tail organizations and products and billions of people. Additionally, review data, articles for news monitoring, discussions with sentiment. These are all commonly available online and have huge potential through web data extraction. So at Diffbot, we've been at the forefront of AI-based web scraping for a number of years, and we've seen all sorts of innovative web scraping uses, from detecting fake news or products to providing valuable market intel or finance signals to getting the first notification of when an org might be breaking environmental regulations, all sorts of uses. And, external data from the public web has many, many uses, and yet we often see it underutilized too, often from improper scraping techniques. So moving forward, the second part of this question is why extract web data? Focus on the verb here. And the root of this question is that there are tons of ways to get data, data brokers, APIs, manually compiling data points. And these are all valid ways to obtain data without automating the extraction of it. But there are a few issues here. So data brokers and APIs only have coverage of specific domains. The range of data here sort of pales in comparison when you compare it to the public web. And while web data extraction is a bit like automating manual data gathering, manual data gathering just can't scale past a certain point, because at the end of the day, there's only so fast that humans can pull facts from the web. The unit cost doesn't get better with more manual extraction. The team just has to get bigger. It's not really sustainable even across single large sites. An example of how much further you can scale web data extraction than manual curation is that even the largest knowledge crowdsourcing projects like Wikipedia are often used as only one among many starting sources for repositories like knowledge graphs, which often scale up through web scraping. Put another way, the very largest compilations of manual knowledge are just jumping off points for scraping jobs. So this is why many organizations turn to web data extraction. It's a standard way to gain data at scale when there's no data provider, or the data provider can't keep up with data changes, or simply the source of the data you're interested in is on the public web. So now that we've tackled this first question, let's take a look at the next one. What are the challenges of web data extraction? So the fact of the matter, sort of corroborated by many studies, is that data teams spend most of their resources on finding, extracting, and cleaning data. The right web data, the right web data extraction setup can dramatically streamline two of three of these steps. So this allows data teams to spend more time on the other portions of their workflow that actually provide guidance and value for organizations. However, you should note the word right in, quote, right web scraping routine. The wrong extraction method still surfaces many of the difficulties of data extraction and cleaning that tend to occupy so much of data teams' time. They don't actually, the wrong choice in web extraction tech doesn't actually alleviate the pain points in extracting and cleaning data. And so on the next slide, we can see some of the challenges that some web scrapers can deal with and other web scrapers cannot. And the factors that play into how efficient web scraping can be include things like Number one, is a site paywalled, or does it change by geographic location, or do they have rate limiting? Anything that might require a proxy. Secondly, is data on a site spread across many pages, or does it require many interactions? Next, does the structure of a site change all the time, requiring you to reconfigure your rule-based crawlers? Next, if you're extracting from many pages or transforming data, do you have robust and reliable data provenance? And finally, do you have processes in place to enhance data that's extracted? So this could be with NLP or machine vision or AI inferring facts. This could show up in the form of you scrape an article and you process it to provide topical tags or entities mentioned in a discussion or sentiment analysis, fields like that. And some web scrapers can do this and others cannot. And so that's sort of the crux of our discussion today, rule-based versus ruleless. And first, we are going to look at rule-based extraction. So what is rule-based extraction? Put simply, it's extraction where for each item you want to extract from a web page, you explicitly declare some descriptor, in other words, a selector. This can occur in visual click-to-extract interfaces. It occurs using CSS selectors or regular expressions. Also, many RPA or robotic process automation routines are similarly rule-based and sort of rigid. If that's all gibberish to you, basically, these are a number of syntaxes through which you can describe what you want. Maybe it's the bolded numerical value that starts with a $sign on a product page. You want the price, right? Maybe it's the number of stars in a review. But the point is that you have to specify exactly what you want to communicate with your scraper. Now, rule-based extraction is probably the most common type of extraction. Historically, it's definitely how web data extraction has occurred. And there are definitely still some advantages and disadvantages here. If you're going to build a scraper from scratch, rule-based extraction is much less resource intensive to create. It's also relatively easy to get started. And if you have one-off or periodic web data needs, it can totally solve many issues. Additionally, many rule-based extractors are client-side, so you can run them when you're logged into a page or behind a paywall if you subscribe to a site or a service. This can be clutch and works in many use cases where you have a relatively small scrape, and it might save like a single knowledge worker some time. On the flip side, rule-based extractors single in on specific descriptions of a location on a web page. So when the web page changes or when descriptions aren't written correctly, these scrapers just don't work. Unlike a human reader who can adapt to slightly different page types or overlook variations, rule-based extractors do not do this. And this is problematic because particularly the sites with the most valuable data tend to change all the time. So the rule-based extractors pointed at them break all the time. This also means that if you don't know the structure of a page you'd like to extract in advance, you can't really run a rule-based scraper unless you just want to bulk grab everything. So you can't really do exploratory crawls on new data sources. There's upkeep and engineering costs to every new page type you scrape. So I'm going to show an example of this. Let me switch screens real fast. But basically here I have a rule-based, browser-based scraper. And let's say in this case, I wanted to grab the author name from a CNET article. So it's simple enough with this particular scraper. And you see that the selector is CSS class current. It's a link element author. That's at least intuitive. We're saying we're getting the author element. You can data preview. This scraper works. If I go to another similarly structured page on CNET, that same selector should work just fine. But let's say we wanted to use that exact same selector on another page. And this is a page that a human could easily parse, right? And it's trivially different. We can see that this is obviously the author name. But when we use the same rule-based scraper, it returns null. And that's going to be the case for every new page type you go to. So this really brings us back to those 2 points. Whenever a page changes, rule-based scrapers break. And you need to specify the value for each field you want extracted from every single page type. And we're just talking about simply grabbing an author field here, just one, not even many data points. With that in mind, I wanted to move on to ruleless extraction so we could have a bit of a comparison here. So I'm going to jump back into our slideshow. And first off, what is ruleless extraction? So in contrast to rule-based extraction, ruleless extraction doesn't require any rules, exactly what it sounds like, to pull out relevant data from a given page type. We've been working on ruleless extraction for close to 10 years at Diffbot, and the idea here is that a vast majority of the web can be categorized into a handful of page types. For Diffbot, this includes discussion pages, article pages, product pages, among others, video page. By building off of a given page type rather than specific pages with specific rules, scrapers can be built to pull relevant information off of a page having never seen it before. For example, a product page may have SKUs, availability, review data, images, and so forth. Ruleless extraction looks for these core components wherever they are and whatever the page layout is by utilizing things like machine vision and NLP. So this is sort of diagrammed to the right of the slide. The fact that machines can obviously read the web differently than humans, and so they can surface hidden fields, things you may not even know to look for if you were declaring rules for a rule-based scraper. With this said, there are definitely still pros and cons for ruleless extraction. Some of the pros include no need to specify given fields with every new page type, no need to fix broken rules when page structure changes, the fact that they work on most major page types, the fact that you can use NLP to return transformed or computed fields like sentiment, topical tags, and then robust data provenance for where page elements come from. A few of the cons, however, are it's resource intensive to create a ruleless extractor yourself, unless you have substantial machine vision, AI, NLP talent at your organization. Also, the simple fact that no single scraper is going to work for every page type. And that's definitely a con of rule-based extraction, but that's a con of all extraction, of ruleless extraction as well. Third, if you have a unique field of interest you want returned, let's say you're looking for something that most people wouldn't care about from an article page or a product page, ruleless extraction may be set up to return sort of a set of default fields that don't include what you're looking for. It's a potential con, but many ruleless extractors you can layer on top, additional rule-based fields if you need to as well. So now I'm going to share a demo of articles from the same two sites we already looked at, but using Diffbot's ruleless extraction, basically our article extraction API. And so basically I put in an article from CNET here. You can see it definitely can pull out the author very quickly, site name, the date, language, has these sort of additive fields where we've then parsed the text value of the article to pull out sentiment and different tags. And note that this is an article extraction API with zero configuration, and that it's also very nicely structured. You can download the results in JSON. And you can sort of see, if we skip to the second example, this time another article from TechCrunch, and actually I'm just going to rerun this just to show how quickly this occurs. This is with zero configuration as opposed to saying, oh, I want these 20 things from a page. Note that you can use our crawler to apply this to thousands of pages in minutes or less. But the important point here is that these are the two sites that we saw a rule-based extraction of simply an author name wouldn't convert, and this is the difference for ruleless extraction here. Also of note, our topical tags are actually linked data. In this interface, you can actually go directly to, say in this case, Lordstown Motors, who are an element in our knowledge graph, which was populated by facts scraped from across the web. And this sort of, and there are a ton of them for, hundreds of millions of long tail entities, which sort of leads us to our next point, which is adding value with web data extraction. So the primary work that adds value in rule-based extraction is simply ensuring you're able to extract the right fields and that your scraper doesn't break. The primary work that adds value in ruleless extraction is integrating other data sources, inferring data points, letting ruleless extraction do a lot of the grunt work that still remains in rule-based extraction. So your data team can really have a much higher value add, a set of value add tasks, layer those on top. And we can sort of see an example of what structured data from ruleless extraction can let a data team jump into with this screenshot. We have an entire demo of this interface if of interest, but note that you can see it's a media monitoring interface powered not only by a list of custom scraped domains where we're pulling from specific sites, but it's been augmented by NLP to pull out different topical modalities, different in this case, noting that there's been an acquisition mentioned in news. And also pulling in relevant data from Diffbot's knowledge graph, which is essentially a database of people, places, and things populated from R crawling, from a web-wide crawl. And the difference between the simplest rule-based extractors and workflows like this highlight the extent to which data gathering can be a pain even when it's automated through rule-based extraction. Rule-based extractors can take up a ton of your team's time and keep you from providing these higher value intelligence or insight steps to a data lifecycle. So yeah, that's our webinar on ruleless versus rule-based extraction. I'd love to move on to a Q&A section if anybody has any questions. If you're listening to this webinar in the future async, feel free to chime into the chat and we will get back to you. So yeah, are there any questions from anybody in attendance? Cool. Well, that's all we've got for this first webinar. Thank you very much for attending, and check back in for our future webinars on structured data, media monitoring, knowledge graphs, how to pull all these things together in custom solutions. Until next time.